Today, we're taking what you know about circles and applying it to arcs in circles. An arc is a section of circumference. So for example, this piece of the outside of the circle from A to B, that's an arc. It's a section of the circumference. So is this piece between A and C. These curved edges are called arcs. One of the most common ways we measure arcs is in terms of degree measure of the angle below them. So if you see this arc AB labeled with 45 degrees, it's telling you that the angle at the center of the circle beneath that arc is 45 degrees wide. There's three different kinds of arcs. Minor arcs are all those arcs that are less than 180 degrees, less than half a circle. So for example, this arc AB is a minor arc, and so is this arc AC. They're both less than half a circle. A major arc is any arc that's more than 180 degrees, more than half a circle. So the arc from A through C to B, that's more than half a circle, that's a major arc. And a semicircle is exactly 180 degrees, like going from B to C. Now, it's really important you understand how to read and write names of arcs properly. For minor arcs, you just need the two endpoints of the arc, and then you put an arc symbol on top. So when they want a list of all the minor arcs, well, you'd say, well, the distance between A and B, that arc is a minor arc, and you put an arc symbol on top. B to E, E to D, and D to A is also a minor arc. And you'd read these out loud as arc AB, arc BE, and so on. A quick note about minor arcs. Just like when you're naming line segments, the order of the letters doesn't really matter when you have only two letters in the name. So if I said BA instead of AB, it means the same thing. It means the arc between A and B, so the order doesn't matter there. Now, make a note that semicircles always need three letters in their names. Here's the reason why. Minor arcs only need two letters because if someone reads, oh, you're talking about arc AB, they know you mean the shortest distance between A to B, not the long way around. But if I want to talk about the semicircle arc A to E going above the circle, because that's equidistant to how far I'd have to go if I made a semicircle below the circle, I have to specify which one I'm talking about since neither is shorter. So I could call this one arc ABE and this one arc ADE. Major arcs also need three letters in the name. So if I want to find examples of major arcs in this circle that contain both A and B, I would make sure I choose one of the points that the arc goes through on its way to its endpoint. So for example, if I wanted to talk about the arc A to D the long way, first off, if I only called it AD with two letters, it would mean the shortest distance between A to D, so that would be the minor arc version. I need three letters to specify that I'm going the longer way around. So I could call it either A, B, D, or I could call it A, E, D. I would not use both B and E. I only need one of them to specify that I'm going this way around the circle instead of this way around the circle. When they ask you for the measure of an arc, they're really just asking how many degrees is below that arc at the center of the circle. So when they want to know the measure of arc to you just say 60 degrees. Pause the video here and try parts B through E on your own. Arc TUR is a semicircle, so that would be exactly 180 degrees. Arc SU is a combination of a 20 and a 60 degree arc, so that would be 80 degrees. Arc RU is the part of the semicircle that's not the 60 degrees, so I would just do 180 for the semicircle minus the 60 degrees here and get 120. Arc TRS is talking about the major arc, starting at T, going through R, ending at S, so almost all the circle. In fact, it's all of the circle except for the 20 degree sliver here. Since a whole circle is 360, just do 360 minus 20. It'll save you a lot of time. So one of the common ways to measure arcs is arc measure in terms of degrees, as you've seen here, but sometimes you really need to know the actual length of an arc in terms of inches or feet or so on. When that happens, here's your equation. First off, you start by calculating the circumference of the circle. Last time we reviewed how you could get that from the radius by doubling it to pi r and putting a pi after it, or if you already have the diameter, just put a pi after the diameter. Once you know the circumference, then you could find the actual length of your arc by taking n, the number of degrees the arc measure has, and putting it over 360, and then multiplying it by the circumference. The degrees over 360 helps you figure out what fraction of the whole circumference your arc is taking up. Here's an example. First, step 1, calculate your circumference. For number 3, they're telling us the diameter, so I would use circumference equals diameter pi version of your circumference formula. Second, make your n over 360 fraction. They want the length of the minor arc in gray, so that would be 120 degrees over 360. 120 over 360, that simplifies to 1/3. So for my total arc length, it's a fraction, 1/3, times the circumference, 6 pi. When I have a fraction times a whole number, I make the whole number look like a fraction by putting it over 1, and I multiply straight across. Don't forget, we're talking about actual centimeters here, so don't forget your units. So this would be 2 pi centimeters long. We'll walk through one more together. For number 4, when they want the minor arc in gray, they're talking about this small sliver here. However, the degree count for that section isn't labeled, so you're going to have to calculate that first. If the whole semicircle is 180 degrees, you could subtract the 150 section and say the missing section is 30 degrees. Now you could calculate your circumference. Diameter times pi is 20 pi. Now you can make your fraction over 360 with the degrees, 30 over 360. 30 over 360 simplifies to 1/12. And then you say, well, that means that this length is 1/12 of the whole circumference. So you do 1/12 times 20 pi. A quick note with all the circle problems today, you always want to leave any fractions that don't simplify as fractions. Don't write them as decimals. With circles, you always leave them as fractions, and you'll really see why later. So leave it as 5 pi over 3. Don't write it as a decimal. Pause the video here and try the rest of the page on your own. Check your answer for number 5. And check your answer for 6 and 7. Great job, everybody. Don't forget to turn in a picture of your notes when it's complete.